Hello, hello. Here we have 8.3. 8.3, number 1. Now in this situation, you're walking, you're running along. As fast as you can, and there's a pipe. And there's fluid flowing through the pipe. Now the question is, this fluid is going as fast as you can go. What would have to be the diameter of the pipe for the fluid to be going the speed of your car? Now, we do know one thing. It's going to have to be smaller. Think about it. If you got a volume of water, in order to get that same volume through a smaller pipe, it has to go faster, right? You're going to have to get a lot faster. But let's figure out how much faster. So, if you'll recall your formula, V1, that would be this section, my velocity, V1 times A1, that would be the area of the pipe, is equal to V2, the velocity of the car, times the area of the other pipe, the area of the cross section of the other pipe. That would be A2 here. So my velocity is V1, car's velocity V2. Now, by the way, why these random speeds? They're just biometrics. Everybody's going to have a different number. Everybody's going to get a different answer. Okay, my max velocity is 5.6 meters per second times, now the area here is 2 meters squared, if memory serves. Or it's 2 square meters, not 2 meters, well, 2 square meters. And that equals V2, now for my car, being a cheap electric car, it's 42 meters per second times the unknown area of the pipe. But we can be pretty sure it's going to be less than 2. So, multiply these together. 5.6 times 5.6 is 11.2 meters per second times meters squared. Ironically enough, the whole thing is meters cubed per second because it's a volume. It's that many cubic meters per second. I mean, what we now have is actually a volume in motion, or the total flux of the pipe, is equal to 42 meters per second times that mysterious area. Divide both sides by 42. I can't seem to write anything today. 42 meters per second over 42 meters per second. Now that cancels. And what we're left with is A2, the small area, is equal to, now I got 0.27. The meters cancels the 3, makes it a 2, so it's meters squared, and the seconds are gone, so it's just 0.24 square meters is the area of the cross section of the pipe. So it's gone from being 2 meters squared to under 1/3 of a meter squared. It's gotten a lot smaller. Now, let's use some number sense. I don't know how fast you are, but if you're slower than me, that's going to make this a bigger transition in speed. And in order to accommodate a bigger transition speed, you're going to have a greater shrinkage of the pipe. So if you're dramatically slower, expect that number to be less. However, if your car is not an economy electric car, it probably goes a lot faster. My car maxes out about 90 miles an hour. Most cars can go well over 100. So that's going to scale this up even more. So, if you're slower than me, you're going to have to shrink this a lot more to get the speed. If your car is faster than mine, you're going to have to shrink this a lot more. So you may end up having enormous restricting of the pipe in order to get that pipe small enough where the fluid is forced to go as fast as your car. But chances are you're probably not going to get a number bigger than that unless you're super fast and drive a car that's super slow. So expect your number to be smaller because the pipe would have to be smaller to get the velocity faster. Okay? Bye-bye.